if you look up the structures for some of these molecules, you might end up having different structures based on who's doing them, okay? Because there's different ways that these things can fit together. But typically, there's only one right answer, okay? So yesterday when you were doing this, if we went around and looked at everybody's, you might have different answers between you. And all of those would have been valid with what you knew at that point in time, okay? But now I'm going to add something else into that. And that thing is called formal charge. And that is what's going to get us all to the same answer. Okay. So formal charge on an atom is in a covalent species. So covalent means that we've got two nonmetals. The net charge on the atom would bear if the electrons in all the bonds were equally shared. These things do not typically equally share all of the electrons. Some things end up being kind of an electron hog, where the electron stays on one end of the molecule more than another. And that comes down to periodic trends and electronegativity. Remember we talked about electronegativity? Okay. What was the biggest electron hog on the periodic table? Anybody remember? What grade do you not want to get in chemistry? What is the element?
Fluorine.
Fluorine, right. Okay. So fluorine is the biggest electron hog on the periodic table. It's going to have those electrons around it more than other stuff. Okay. So, and that goes down to so oxygen more than hydrogen and chlorine more than hydrogen and that sort of thing. Okay. So it comes down to that electronegativity. Remember, as we move across our periodic table, it's going to let me write today, you guys, at least for right now. Right over here is your highest electronegativity, and it gets less and less as you move down that direction. Okay? So when these things form bonds between these elements, they are not always equally shared. And so when we're looking at that, we come down to this idea of formal charge. Okay? Now, how do you calculate formal charge? There are some fairly complicated equations for this. I find that this works best for everyone. Okay? So the formula that I throw out is should minus has. But if you look this up on the internet, other people have other formulas and other ways of doing it. We all come to the same answer. Mine's easier. Okay. I didn't develop this. I stole it off of YouTube. Okay. I went through about 5 or 10 different YouTube explanations of formal charge, and I was about in tears until I came across this one. And I'm like, oh, that's easy. I can do that. And you'll find it's easy as well. Okay. So to calculate formal charge, your should part of this is the number of valence electrons that they should have. So you just look on the periodic table, 1, 2, 3, 4, 5, 6, 7. Okay, you can do that. Okay. The has is the number of electrons directly attached to the atom. Okay. And the best structure for that is one with formal charge as the lowest possible, and it puts that negative formal charge on the most electronegative element. When counting the has, now this is the only time you do this. When you're counting the has part of this, a bond is just one electron. Okay, that's the kicker. That's what you got to kind of remember. All right. So let me go through this with you and show you some examples, okay? Because it makes sense once we get through here, okay? All right. First one here is we've got 3 different structures. So like I was saying, you can draw these in different ways, but only one of these is correct. And we're going to figure out using formal charge which one of these is the right one. All right? So nitrogen. How many electrons should nitrogen have? What column is it in on the periodic table? 5. So it should have 5. Okay. Now we're going to count how many it actually has. So this is my should minus what we're calling has. Okay, so I'm going to count these. 1, 2, 3, 4, 5, 6. And this line only counts as 1. So that is 7. The only time that line only counts as 1 is when we're doing formal charge.
Do you want me to pick up these and these?
Those go in the little gray cabinet. You might have to move the boxes to get them to fit in there. Okay, so should is 5 minus has is 7. What is the formal charge on this nitrogen? -2. Okay, now I'm going to do my carbon. How many should carbon have? It should have 4. Okay, how many does it have? 1, 2, 3, 4. So its formal charge is 0. Sulfur. Sulfur should have 6. How many does sulfur have? 1, 2, 3, 4, 5. So its formal charge is a +1.
I'm confused.
Okay, let's do another one then. All right. Nitrogen should have how many? What column is it in on the periodic table, right?
5.
5. Okay. Now we're going to count how many it has. So my valence electrons.
1, 2, 3, 4.
So valence electrons 1, 2, 3, 4, and then each line counts as 1, 5, 6. 5 minus 6 is
-1.
a -1.
Got it.
Okay. Carbon then, we said before, and it stays the same, should have 4. It has how many?
1, 2, 3, 4.
4. Yep. So 1, 2, 3, 4. So its formal charge is 0. Sulfur should have 6. How many does it have? 6. 1, 2, 3, 4, 5, 6. So its overall charge is 0. Now you do the next one. Okay. Did you do okay with those? All right. One thing that I want you to notice as we're going through here, if we are dealing with a polyatomic ion, this is a polyatomic ion. Remember we talked about those, how it's these nonmetals that are bonded together and they carry a charge. Whatever your formal charge, your overall formal charge here should equal what the charge is on that ion. So here, -2 plus 0 plus 1 is a -1. Here, -1 for this one, and we've got a negative charge here. Here is your -1 and a -1. Okay? So all molecules, their overall formal charge will be what? Do they have any charge? No. So all molecules will end up having a 0 formal charge. So when you get done, you can check the formal charges on each of the atoms in there. And if they don't add up to 0 and it's not a polyatomic ion, something went wrong. Okay? Now, we need to figure out which one of these structures is best. Okay? So first of all, first rule is if you can you want to have as little formal charge on the atoms as possible. So that is going to very quickly eliminate this first option here because we have formal charge on 2 items. That's bad. Okay, if we can build it to where we have a formal charge on just 1 atom and none on the other ones, we want that. So you want to minimize as much formal charge as possible. So getting rid of this first structure helps us out there. Now we need to figure out which one of these is best. If we go back to here, we can see that one of our double underline really important points is it's going to be on the most electronegative element. Okay? And you would have to be given a chart of electronegativities to be able to figure that out. I'm just going to give it to you. Okay? Nitrogen is more electronegative than sulfur. Okay? So we want the negative formal charge to be on the nitrogen and not on the sulfur. So that's why that is the preferred structure. Okay? Otherwise, they would give you a chart of electronegativities and you'd be able to figure it out from there. Okay? I forgot to put that on here. Fluorine, oxygen, nitrogen are the most electronegative on the periodic table. All right, let's check, see if you can calculate the formal charge between these two. Again, 2 different ways to draw this molecule. If you had to draw this yesterday, I would have to accept either one of these. Now you know about formal charge, so it's going to be one or the other that gets accepted. Okay, so figure out what the formal charge is on each of these. Hydrogen should is 1 and has is 1 because it's, it's just that S. So 0. Are you able to get those for the formal charges for each thing? If you weren't, talk to me so we can go through it. I don't want to spend time on stuff that you understand how to do, but if we need to spend time on it, let's spend time on it. Good? All right, which structure is preferred, the first or the second? The first, yeah. This one has 0 formal charge on all of the atoms. Here, we've got formal charge on 2. So that just in and of itself is going to eliminate that idea. Okay? Now, here, this carbon is less electronegative than oxygen. So we wouldn't want, if we had to go with a structure like this, we wouldn't want this one because it's got the negative value on the less electronegative element. So that one's bad for 2 reasons. Make sense? So this is how we get down to like one right test answer. Okay? Like, but there's so many different ways. But are there? All right. So see if you can draw your NO3 minus. So see if you can draw that structure and base it on formal charge. And then we're going to talk about like who got what answer and see what you ended up with for the drawing for that guy. 25. We're still going good. We got 20 minutes. The last part of this stuff doesn't take long. Speaking of which, do you all know next hour whether you're going to the assembly or the class?
I don't know.
Okay, let me look that up for you real quick here. What class do you have?
English.
So English, I thought they switched those. I better check the email one more time. Please note, art and English, you will be attending the second assembly.
Okay, sorry.
So you're going to class next, and then you're going to go to the assembly. Anybody else? Everybody's good?
I believe world language is first assembly, right?
Yes. So you're going to the assembly, and then you'll go to class. All right. Anybody got NO3 drawn yet? Anybody feeling confident enough to draw it on the board? It's a minus, by the way. Did I talk to you guys about minuses and loose dot structures? Maybe I should do this one with you. I'm sorry. Maybe I forgot about that. So let's talk about valence electrons with these minus charges. Nitrogen has 5, right, for valence electrons. Each oxygen has 6, but we have how many of them? 3, so that's 18. And then because this has a negative charge, that's going to add in an extra electron. So that is going to give us a total of 24 electrons that we're working with. Does that make sense? That minus charge gives you an extra electron because electrons are negatively charged. Okay? Does that help drawing a thing?
I just forgot everything.
Okay, so what is going to go in the center? Nitrogen. Okay, and I'm going to attach my oxygens off of that nitrogen. So right now I have 6 out of my 24 attached.
24?
I had 24 electrons. So nitrogen gave me 5. Oxygen is 6, but I've got 3 of them. So 6 times 3 is 18.
Right.
And then this negative charge gives me an extra one. Okay, so I'm up to 6 out of 24. And now I'm going to go around and work outside in. So I'm going to work with these guys. And I'm going to go 2. So that's 20. That was 6, 8, 10, 12, 14, 16, 18, 20, 22. Now, if I put the final 2 dots on this oxygen, what problem am I going to have? I'm not going to have enough for the nitrogen. So what do I need to do? Double bond. So I'm going to double bond here. And then the last part of this drawing, because this is a polyatomic ion, because it's an ion, we have to show that charge. We use square brackets and we put the charge outside of it. Okay. Now, when we calculate our formal charge for this, the oxygens, we're going to have different values for these oxygens versus this oxygen. Okay, so let's look at the formal charge here for our oxygens. I did that. Let's do purple. Okay, for this oxygen here and this oxygen here, their formal charges are going to be the same, right? That makes sense? Why? So they're going to be 6, which is oxygen, minus what? 7. 1, 2, 3, 4, 5, 6, 7. So it's going to be a -1 charge. So I'm going to have a -1 formal charge here, and I'm going to have a -1 formal charge for this guy. Does that make sense? All right. Let's look at our nitrogen. Nitrogen should have 5. It has how many? 4. So it has a formal charge of 1. This oxygen should have 6. It has 6. 1, 2, 3, 4, 5, 6. So it is at 0. Now, if we look at the formal charge for, oh Lord, that's big. Let's see what that is. Tiny as we can get it. Okay. If we look at the formal charge for these, we've got a -1 here, a -1 here, a +1 here, and a 0 here. What is my, that's a -1, -1, so it's -2. +1 gives me a -1. That's where they get that -1 on the outside here. Does that make sense? Oxygen is more electronegative than nitrogen, so our negative charges are on our more electronegative element. So that's a good thing as well. Okay? See if you can do HCN, or HCN. See if you can do that and come up with the formal charges on that structure. Drawing on me? Fast. Good job. No, I want one. That's good. Thank you. Oh, yeah. How many does nitrogen have? How many does it need to have to be stable? We learned yesterday. It needs 8. It needs an octet. How many do you have? You have 6. 2, 4, 6. Remember when we're doing loose structures, it's only formal charge that you're counting the bonds on. Okay.
Oh.
How many does oxygen have around it, or nitrogen? It has 10. 2, 4, 6, 8, 10. All right, looks like most of y'all are finishing up. Okay, you need to make sure when you're doing these that you're remembering that these can only have 8 to be stable. Okay, so I went around. There's a couple different ones that were drawn. I want to talk about those. So first of all, here with this one, when I saw this one, it has 10 electrons total. Well, they've got all 10 around just this section. So they really have 12 drawn here. So 2, 4, 6, 8, 10, 12. There was only 10 electrons here. Also, this nitrogen can only have 8, and carbon needs 8. So this one only has 6 for the carbon. Okay, this is learning. This is great, you guys. I'm not upset that you had different drawings. Okay, this is how we learn these things. It's practice, practice, practice. I had another one drawn like this: 2, 4, 6, 8, 10, 12. Again, too many electrons. And the nitrogen here only has 6 electrons. Okay, so we're going to get rid of that one as well. Try to anyway. And then the last one I had walked around and found this one: 2, 4, 6, 8, 10. So perfect. You've got the right amount of electrons, but this carbon only has 4 electrons and it needs 8. Okay. So make sure you go back and double check your Lewis structures. Now, with this, if I have 4 electrons drawn here now. Okay, I've just got kind of my base structure started. I'm going to work from the outside in. Okay, and this is how some of you ended up with this guy. All right, but the problem is if we stick with that style, carbon doesn't have 8, and we need to get 8 there. So what do we do when we need more electrons? We double bond. Yep. So I'm going to take these 2 here, and I'm going to bring them in. Carbon happy now? Is carbon happy? No, carbon needs 8. So what do I got to do? Double bond again. Well, not double bond, we're actually triple bond. We're going to bring it into there. Okay, now I saw somebody with their lone pairs of electrons at the top, and I saw some with them on the side here. It doesn't matter. It's fine. Okay. And then we check our formal charge. Should have 1, has 1, so it's at 0. Carbon should have 4. It has 1, 2, 3, 4. 0. Nitrogen should have 5, and it has 1, 2, 3, 4, 5. So again, we're at 0. So that is the preferred structure. Is that making sense? Okay, I've still got time. You guys do not need 6 minutes to pack up. You're fine. All right, bond order and length. This is super easy, you guys. So when we're looking at bond order, you look at how many sites, how many places that the things are bonded, and you look at how many bonds are there. Okay, so this is 3 bonds at one site. So for this guy, 3 divided by 1, its bond order is 3 divided by 1, 3. Okay. Here, for this bond, we have 1 bond at 1 bond site. That bond order is 1. 1 divided by 1 is 1. The bond order for this carbon-carbon bond, you've got 3 bonds in 1 bond site. So it is, 3. Okay. And then the hydrogen would be the same as the previous hydrogen. So draw the Lewis structure. Determine the type of bonds. Are they single, double, triple? Higher bond order indicates higher stability. It's going to be more stable. And then we need to talk about something called resonance. Let's figure out our bond order for this guy. We've got carbon is 4 plus 5 for our nitrogen plus 1 is 10 electrons. Excuse me. So then I need to do my square brackets because I have a negative charge on this. This is a polyatomic ion. It's called cyanide. Some of you might have had cyanide for your Poisoner's Handbook option studied. That is due today. What is my bond order for this? How many bonds do I have?
3.
How many bond sites do I have? 1. 3 divided by 1 is 3.
1? Oh,
I only have one spot. This is getting bonded.
okay.
Can you have more than one?
Yeah, we're going to get into it. I'll take you back up to that. Let's go back up to this nitrogen here. Okay. We can do an overall bond order for this nitrogen. And when we look at that, I'm going to switch this orange pen here. Or maybe blue would be better. Let's do blue. Okay. So when we look at this, if we want to know the bond order for the nitrogen, okay? And this is going to come down to something called resonance, which I'm going to have to get into tomorrow. When we look at this, okay, we end up looking at it, and our nitrogen has 1, 2, 3, 4 bonds. How many bond sites? 3. So its bond order is actually 1.3. Okay. So yes, and I'll have to get into resonance. Now for tonight, what I want you to do on this homework here, okay, is you should be able to do, well, you should be able to do all of that. You should be able to do that one. That you should be able, yeah, you should be able to do all of this. And then I'll talk about resonance tomorrow. I'll continue the notes with that. But okay, everybody knows where they're going.